Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over the method of successive approximations. So let's get into this. Okay, so in this video we're going to talk about successive approximations. We're going to go over an example and then in another video I'll go over some more examples. But we'll go over one example here. So let's talk about successive approximations. This is a method that you can use when your x is too small or the x is negligible assumption is not valid. It doesn't pass the 5% rule, and so you have an option here. So either you'll have to do a quadratic equation and use the quadratic formula, or you'll have a higher order polynomial that you're going to need to solve, right? So you could either do it that way, or you can use the method of successive approximations in order to solve the problem. So this video I'm going to be showing you the method of successive approximations, and I'll show you how that method can actually be a lot easier and quicker than just plugging and using the quadratic formula for second order polynomial equation. So let's get into the example here. So here I have an example. Oh, and by the way, this can be used especially in acid-base reactions when you have your Ka value, right? And if the Ka value is not small enough, in order to have a small amount of your acid dissociate, right? So if your x value is not small enough, then it won't pass. So this works also for your acid-base equilibria as well, since we're dealing with equilibrium reactions, and acid-base or acid-base reactions are also equilibria. Okay, so here I have an acid, right? So we have this acid here, which is your acetobromic acid. And so that's going to react with water to form your hydronium ion and then the anion left over. And so in this example here, I have 0.200 molar, and I have water here. Now, water is not really part of the reaction, or at least it's not aqueous, right? So again, liquids and solids and gases, gases can be in the equilibrium constant expression, but remember, solids and liquids aren't. So water's a liquid, so we don't include that in our expression. So we're not really going to do anything with the water. Here we have hydronium, and these are aqueous. We start with zero amount of those. So because we have zero products, we know that it's going to shift in this direction to make product, since you can't have zeros at equilibrium. So that means that we're going to lose an X amount here, and we're going to gain an X amount here, and we're going to gain an X amount there. And so when we add these together, we'll get our equilibrium expressions at equilibrium of our different species. So here we'll have 0.200 molar minus X. We don't need to have the molar in there, right? So we'll just have minus X. And here we'll have 0 plus X is just X. And here 0 plus X is just X. Okay, so now we have our equilibrium concentrations in terms of X. And so here we have our KEQ. Since this is an acid dissociation or acid ionization process here, that's going to be the same as our Ka value. So remember, Ka is just the equilibrium constant for an acid dissociation reaction that's going on here. So we're given the Ka value is 1.3 times 10 to the negative 3. Notice that the 1 times 3 times 10 to the negative 3 is not a very small number, and so we would expect the x value, the change, to be very slight, or not very slight, sorry, is going to be not very slight. Basically, our x is probably going to is going to be too big, because we're going to have more dissociation than we want in order to say that x is negligible. So all that is to say is that our x is probably not going to be negligible. So we'll set up our expression. So it's going to be the concentration of the hydronium ion raised to the 1 power, since all of our coefficients are 1. So that's going to be multiplied by the concentration of this here. That's going to be the anion, so C2H2BrO minus. And then all of that is over our reactant here. Again, we're ignoring water since that's a liquid. So it's going to be over the concentration of the acid. So HC2H2BrO. And so now that we have our expression, we can plug in these into the our expression here. So for hydronium ion, it's going to be X. For this anion, it's going to be X. So that's going to be equal to X times X over, and then we have the acid here, the acetobromic acid. So that's going to be the 0.200 minus X. So 0.200 minus X. So now that we have this expression here, we can now try the X is negligible assumption, and we can get rid of the X here and solve more easily. So let's go ahead and do that. And so what I would recommend also, before I forget, is anytime you do any of these sorts of equilibrium problems where you are solving for X, if you're able to, you should always just go ahead and just eliminate X and assume that it's negligible, even if you have a thought or idea that it might not pass. Because one, if it does pass, then great, your X is negligible assumption is valid. But then if it doesn't pass, you've already done the first step that's required in the method of successive approximation. So you've already done the first step that you're going to do anyway for this method, right? And if it turns out to be valid, then you're already done. You're good. Okay, so we're going to assume that X is negligible, and so we'll solve for X. 1.3 times 10 to the negative 3 is going to be equal to X times X, which is X squared, over, and then this is going to be 0.200. So now all we need to do is multiply both sides by 0.200. So we'll multiply this here by 0.200. So then we'll multiply this together, and when I do that, I get, let me calculate this really quick. So when I calculate this, I get 0.2 times 1.3 times 10 to the negative 3 equals, and I get 2.6 times 10 to the negative 4, right? So I get 2.6 times 10 to the negative 4, and that's equal to X squared. So now all I need to do is square root both sides, right? And then I get X is equal to, what did I get? 0.016, 0.0161 1. So I add another digit there, even though it's only 2 sig figs. I'm adding another digit for rounding errors because we're going to do this calculation again. But first I want to show that, you know, if we see, we'll see that this does not pass the 5% rule. So let me do the calculation over here. So the original concentration was 0.200 molar. So if I take my X value, 0.0161 divided by 0.200, and then multiply that by 100, I'm going to get pretty much 8%. Now 8% is definitely greater than 5%, so this does not pass the test, which means that this X value is not negligible, so I can't assume to be negligible. However, the thing you want to keep in mind is when we say that X is negligible, we're essentially, when we get rid of the X here, we're saying X is 0, right? That's essentially what we're doing. So, oh, X is 0, so I'm going to get rid of it, and then I have 0.200 here. But this here, even though X is too large to say is negligible, this is a closer approximation to what the real value of X is compared to saying X was 0, right? So X can't be 0. So at least this is a good starting approximation, although it doesn't pass the 5% rule. Now here's where the successive approximations method comes in. What I can do is I can take my X value, we'll call this X1, right? This is my first X value in the iteration of the process of finding what my actual X value is going to be, what the real value is. Now what I can do is I can take this X value that I got and then plug it back into the X here that I had said, oh, it's negligible. Well, now I can take this and put it in there and solve again, right? So then I'll erase this here. Let me get rid of this, okay? So now I can take this and say, well, okay, so now I have X squared over 0.200 minus this. So I'm just going to plug this into X, and so I'm going to solve for X again. This for my second value of X. So this is an iterative process, meaning that I repeat it over and over again. I do the same calculation over and over again, each time putting in the previous X value that I got again into the expression here until I get the exact same X value spit out before. So once I get the same X value twice in a row, I know I'm done. I've reached the correct answer. So then I'm going to put this in here. So it's going to be 0.0161. And then when I solve that, I get, let me see what I get. So I'm going to subtract, let me subtract. So 0.2 minus 0.0161 equals, and I get, oh, and by the way, this is again equal to 1.3 times 10 to the negative 3, right? So it's equal to the Ka. So then, let me erase this, I don't need that anymore. So then this is X squared over, what I get, 0.1839 equal to 1.3 times 10 to the negative 3. So again, excuse me, I'm going to multiply both sides by 0.1839. Multiply this by 0.1839. So that's going to cancel out and end up with X squared is equal to this times this. And when I calculate that, let's see, multiply by 1.3 times 10 to the negative 3 equals, I get 2.3907, 2.3907, 2.3907 times 10 to the negative, what is that, 4. Okay, and then I just take the square root of both sides again. So I'm going to take the square root of that. I'm going to take the square root of that. So then when I do that, let's take the square root. Oops. Okay, hold on a second. I'm going to take take the square root of 2.3907 times 10 to the negative 4 equals, and I get 0. So here I get x is equal to 0.015. 0.0154, right? So again, I'm going to just keep one extra digit. So that's my new x. So remember, my x, this is x number 2, right? So my first x was this value. My second x is this one. Notice it's different. And so this tells me I'm getting closer to the actual value. So now I'm going to do it again, and I'm going to see if I get the same answer. If I get the same answer I got for this one, then I know I'm done. If I don't, then I got to do it again until I get the same answer twice in a row. So let's go ahead and do that. So that's my new x value. So I'm going to do the iteration again. So I'm going to plug this x2 into x there and solve. So I'm going to have x squared over 0.200 minus 0.0154, and that's going to be equal to 1.3 times 10 to the negative 3. And so let's go ahead and calculate this out. So I get 0.2 minus 0.0154 equals, so then I get x squared over 0.1846 equal to 1.3 times 10 to the negative 3. Again, multiply both sides by the denominator here. 0.1846. Multiply this by 0.1846. So this cancels out, and I get x squared equal to these two things multiplied together. So let's go ahead and multiply 1.3 times 10 to the negative 3 equals, and I get, what is that? 2.3998 times 10 to the negative 4. And then again, all I do is I take the square root of both sides, and therefore I got x, third x, let's do this, so it's oops, let me try that again. So I got 2.3, oops, so I'm going to take the square root of 2.3998 times 10 to the negative 4 equals, and I get, again, 0.0154. Again, the third digit is just an extra digit to avoid rounding, but notice that I now have the same answer twice in a row, which means that I have gotten to the actual answer for x. So now I know what the change is. So now what I can do is I can take that value and plug it into x here and x here and x here. So what that means is that for this, concentration at equilibrium for the acid is going to be 0.2 minus, 0.2 minus 0.0154 equals, and that's going to be 0.184. So this is going to be 0.184. The 4 is just an extra digit, right? If I want to round to two significant figures, I just do 0.18 molar. And then for these two, it's just x. So the concentration would be 0.015 or 0.015 molar, right? So those would be the concentrations at equilibrium. And so that, ladies and gentlemen, is how you do the method of successive approximations when you have an x value that is not negligible and you want to avoid using your quadratic formula or trying to solve any higher order polynomials, right? So I hope this is helpful. If you had fun watching the video, if you learned a lot from this video, if this helped you in any way, then please by all means like the video, share the video, hit that like button somewhere down here. Also, subscribe to the channel and help me out. When you do that, click the notification bell above and click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.